Okay, last lesson you were asked to complete this activity. So what we are going to do is we're going to look at solids, liquids, and gases. And what I want to do is discuss three properties: motion, arrangement, and bonding. Often in exam questions, they like to discuss the idea of properties such as motion and intermolecular forces, i.e. bonding. Sometimes it's arrangement as well. So let's do it step by step. First of all, solid, the motion of the particles in a solid, the particles vibrate around fixed positions. The arrangement, the particles have a fixed volume, fixed shape, and a solid cannot be compressed. Bonding, the particles have strong intermolecular bonds between them. And these are the statements that you have to mention when you are writing out your answer in your exams. Liquids, particles can slide over one another, and the particles are moving faster than solids. They are fixed in volume and cannot be compressed. However, they can change shape easily, and liquids take the shape of a container. The bonding is weaker compared to the solid, strong enough to keep the particles together, however, not strong enough to stop them sliding over one another. Gas. The particles are in random motion. You need to explain this. So the particles move in different directions with a range of different speeds. That's what random motion means. The direction is continuously changing and the speeds are continuously changing. If you were asked a question to compare the motion of a gas compared to a solid, you could make a statement that the particles move faster in a gas compared to a solid. The arrangement, particles are arranged with no fixed shape and gases can be easily compressed. Often there are no intermolecular bonds between the particles, and if there are, they are very weak. So when you are comparing, often in your exams, the examiner on several occasions have compared solids against liquids. You would compare the motion between solids and liquids. You will compare the bonding between solids and liquids. And if in the question they ask you to discuss arrangement, then you will discuss the arrangement as well. This has come up several times as a 6-mark question. Now, how will this appear as a particle diagram? Now, I've put this up here. Solid particles, you got to draw them as circles and joined together in a nice compact way. Liquids joined together on many occasions, but spread out. You can see some gaps. Gases not joined and spread out over the same area. Now, a summary of changes of state. So if I have, let's say, a Bunsen burner, I'm heating a beaker with some water inside, and there is an ice cube inside the water. And let's say I am able to measure the temperature of that ice cube. Considering I've just taken it out from the freezer, that ice cube will be around about minus 20 degrees. So I've called it minus 17 degrees. That's the temperature of the ice cube. Now, when I heat up this water that's in the beaker, that's going to transfer that heat energy to the ice cube and heat it up also. So over a period of time, this ice cube is getting hotter. Let's say go from -17 to -16 and so on and so on and so on. And if I was to plot these temperatures over a period of time, what I'll see is the temperature was increasing over a period of time when I am heating the beaker with the ice cube in it. These are results for the temperature of the ice cube, not the water, but the ice cube. So what's happening is the temperature of the ice cube is going up and up and up. Now, eventually what's going to happen is at 0 degrees Celsius, the ice is going to start to melt. It will only melt at 0 degrees, not at any other temperature, not -12 or not -6, only at 0 degrees. So let's have a look. Once the ice gets to 0 degrees, so this temperature here, 0 degrees, the heat energy from the Bunsen burner that's given to the water is now gone into melting the ice. So if you notice here, when the melting process starts to happen, the temperature stays at 0 degrees. It doesn't change. So the temperature is not going up when the ice is melting. So where is all that heat energy going? So this is something that we are going to consider. When the ice was -17 degrees, we gave it heat, it started to increase in temperature. But when we got to 0 degrees, we gave the ice heat. Now the temperature stopped going up, but it started to melt. Okay, so when the temperature becomes constant and doesn't change, we say that the solid is changing state from a solid to a liquid. Okay, now